Hi, so welcome to my flyer of information processing in multiple intelligences. So first we're going to start with information processing, which the simplest way to describe this is basically that your brain works like a computer. So think about how a computer runs. That's really what this theory runs on. That people can input data, it can process it, and it can spit it out, basically, just like a computer would. So starting off, we need to talk about the input of data, which occurs when your mind can use its senses to interpret or use the information it deems fit. So if you're in a classroom that day and you're learning the quadratic formula, it might help you to remember what the paper smelled like, or what it felt like writing down the formula, or different kind of processes your brain uses to help remember what you were doing. And so this kind of idea goes along with being a computer because you're inputting the data into your brain. It is using whatever process to run through it and store it, just like a computer would. So first, for this theory, we need to look at the assumptions. So these are the four things that for this theory to really work, we have to assume. And first is that information is processed by many processing systems. And by processing systems, this really means in your mind. So in your brain, in many different parts of your brain are being used. And so an example of that I haven't read is short-term memory. So this theory really doesn't work if many parts of your brain aren't being used, because that's really what makes this important, because you have to use different senses to basically process the data that's being put into your brain. By data, I mean things you learn in class, like not actual data like computer, but I'm going to keep moving with this metaphor. So number two, these processing systems transform the information. So basically, when it goes into your head, it gets interpreted in your own way. It gets put into your own words, just like how I used from the reading, I interpreted these definitions into my own words. And three, the research is looking for progress and structure in cognitive development. If the research isn't looking in these areas, this theory really doesn't matter. So we have to assume that that's what research in cognitive development is really looking at. And number four, information processed by humans resembles computers. I'm even assuming that because I'm going to keep using this metaphor over and over again. And that's what the current research shows. But again, anything could change because science is always evolving. And so processing. Information processing is composed of three different stages. So first is the input processes. And this is concerned with the analyzing of stimuli. So basically, when you input something, your brain has to analyze it. And then it goes into the storage processes, which is how the brain internalizes that stimuli. And lastly, the output, which is responsible for the correct response to that stimuli. And so then let's move on to attention, which is basically about multitasking, and that in this theory, multitasking cannot really occur because you kind of have what's called selective attention. And a good example of selective attention would be if you're writing your thesis. So it could be about whatever you're interested in, and your phone rings next to you and it shows a text message. Your selective attention is that you can only do one of those things at a time. Either you respond to the text message or you keep typing your paper. Whatever you choose doesn't really affect, but it affects your learning because you're choosing really to pick your phone over the learning itself. And this is not multitasking. So basically, the short answer is that we can only process so much information at once. We can't do multiple things. But then if we go into the critical evaluation of this theory, there's a number of questions that is raised by the idea that our mind is a computer. So first, it assumes serial processing, which means that you can only start a task after you finish the last one. So, but as we know, multitasking can exist. And that's where we look at this red word called parallel processing, which is basically that people can work side by side on two different things. No, you can't do like write two papers at once, one with your right hand and one with your left hand. but people can do multiple tasks at once. Like you can listen to music and write a paper. You can focus on two different things. So number two, the connections between humans and computers is limited. It gets hard because humans have emotional attachments to things that computers don't. So it's hard to really measure this as opposed to computers because there's a whole nother layer to humans that computers don't have, and that's our emotional state. And three, the experiments used lacked the social interactions that because these were done in a lab. So basically, this goes along with the computer thinking. Humans have emotions, and they conducted these experiments to test their hypothesis in labs, and that just can't be replicated the same way it can be in a classroom. And number four, this is completely stimulus driven and doesn't really account for any of your past experiences. So let's say you're trying to learn how to ride a skateboard or something. It doesn't really use the way that, oh, you rode a surfboard, so you already started a little bit up. It just looks at the stimulus for what it is.